So in the introduction to Chapter 2, we discussed measurements, what they are, the two parts of a measurement, how we can use the terms accuracy and precision to say something about a measurement. Now let's talk about measurements in terms of scientific notation. So many times, scientists have to make measurements that are really big. So for example, if you are a physicist or a cosmologist and you're studying the size of the universe, chemists usually make measurements that are very small, like the size or the radius of an atom or the size of a virus. Okay? So measurements can be really big or really small, depending upon what you're studying. So there needs to be a way, scientists need a way to write numbers that are really big or really small with still saving their wrist so they don't get carpal tunnel syndrome without having to put a bunch of zeros before or after a number. So to write a number that's very big or very small, scientists make use of scientific notation. So scientific notation has two parts, a decimal part and an exponent part. The decimal part of scientific notation is essentially the first number of the measurement, the decimal, and the rest of the number. That number needs to be between 1 and 10. So what that means is that for the decimal part, there's only one number in front of the decimal. So it would be, so in this example, it's 1.2, not 12 point something. Okay? The decimal part, that is the decimal part, with the one number before the decimal. The second part is the exponent part, and the exponent part is always times 10, and that 10 is raised to some exponent, and that exponent tells the scientist the direction and the number of times the decimal in the original number needed to be moved to get it to where it is in your scientific notation. So, what exactly does that all mean? Let's do two examples. Actually, we'll do a third example as well to determine scientific notation for a number. Let's say I was to have this number 5,983 and I wanted to write it in scientific notation. Well, I know that scientific notation, I need to have the decimal part, so I need to have the first number, which in this case is 5. Then I have a decimal, and then the rest of the number, 983. So that's the first part of the scientific notation. The second part, I need to use the exponent to say something about how many times and in what direction I moved that decimal point to get it to where it is in scientific notation. Now, looking at the original number, I know there's no decimal point there, but there's an implied decimal, 5,983. And so to get that decimal point in between the first and second non-zero number, I had to move that decimal place 1, 2, 3 times. And since I moved it 3 times, my exponent is 3. And since I moved that decimal point to the left to do that, my exponent is positive. So my exponent is going to be positive 3, or just 3. If I had moved my decimal point to the right, which is what needed to be done with this second number, to write this number in scientific notation, I needed to take my decimal point and move it 4 places. Since I moved it 4 places, my exponent is going to be 4. But I moved it 4 places to the right. And so anytime you move the decimal point to the right, when doing scientific notation, the exponent is negative. So that's why I have a negative associated with that exponent. So another way to state these two rules is that big numbers, numbers that are greater than 1, have positive exponents. Small numbers, numbers that are less than 1, have negative exponents. Both rules will still give you the correct answer for writing numbers in scientific notation. So let's do a third example. I said that chemists love to do measurements that are small. Here we have the measurement for our radius of an atom of lead. Is this number in meters? What is this number in scientific notation? Well, in scientific notation, I have to get this decimal point in between the first and second non-zero numbers. So that means I need to take this decimal point and move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have moved it 10 places, and I've moved it to the right. So my exponent is going to be negative. So my number in scientific notation is 1.54 times 10 to the negative 10 meters. So you should know the two parts of scientific notation, the decimal part and the exponent part. You should feel comfortable given a number, being able to write it in scientific notation. And also doing the reverse. If I was to give you a number in scientific notation, you should be able to write it longhand as well. And there are many examples on the Chapter 2 worksheet on Canvas that have been provided for you. I encourage you to try those and check your answers. But that is how you write a number in scientific notation. In the next video, we're going to talk about how to put a number in scientific notation in your scientific calculator.